Welcome back to LocalM Tuts. I'm Nilay. This is lesson 5 of 16, building your first A2A agent. Last time we set up a development environment, Python, the A2A SDK, GitHub Models, and the course repository. If you're watching this as a standalone video, please find the course playlist link in below description. Before we dive in, here is what you will find all the code for the lesson, including the GitHub repository, and the interactive tutorial link is available in the description below. You can find them in the course submodule. Clone the repo, open the lesson folder, follow the README, and you should good to go. We will build a QAAgent class, an asynchronous Python class backend that wraps OpenAI compatible API. It loads insurance policy, document as context, construct the system prompt, and answer the question using the Phi-4 via the GitHub portal. 3 key concepts. First, the OpenAPI compatible API pattern with some SDK, different ways URLs. Second, system prompt with knowledge injection. And the third, async first design that we will wrap as a A2A server in the next session. Let's see this is in action. Open your terminal, navigate to lesson folder, and run the QAAgent standalone. We will ask it the question about the insurance policy, and let's see the response. Follow along, pause the video if you need catch up. If you haven't got Visual Studio ready, you can also use our website to have an interactive GPT session. Other than running, you can probably access the example, the outputs, everything, along with many other important content. The link for this website of the course is in the description. Please feel free to find. There is also a link for that example on GitHub. That's the same link available, and you can find the example that we're talking about. It's very well documented and you can access it straightforward. Now, I have loaded that example into Visual Studio Code, and let us see what we have done here. As described earlier, we are creating a very simple configuration, which model it need to use in a second block, and then in the step 2 we are configuring the client based on what selection we have made. The quick model test whether it works or not. So let's run up to this point. Execute all the mouse steps, and let's see how we go. Yes, so we got all of the above steps been run. Now, just a quick test. Well done. It has run, and the answer is coming back correctly. 2 plus 2 equal to 4. Let's load the domain knowledge. Now, bear in mind that policy.text will be replaced by the content of insurance policy. So this is just a simple insurance policy we have created, and it will be replaced here as a system prompt for knowledge injection. So let's quickly run this thing to configure. It's been run. Now we are building the QAAgent. This is the most important aspect where we are coming. It's a simple Python class you can actually create into any supported language. The same way, it will configure model, endpoints, API keys, everything, the knowledge, the system prompts, and most importantly, it's just exposing one method called query. So whenever it's been, whenever our client was sending a query, it will run this particular piece of code and find an answer. So let's see. Let's run this class. Let's run the test the QAAgent. So I'm just trying to find. Yeah, all good. So very first question, what is the deductible for the standard plan? Question, printing. So far, it's just a simple chat completion with some sort of open developmentation. There we go. The answer is correct as per the expected lines. Standard class, standard plan, deductible, emergency deductible, and prescription drug deductible. We sometimes call it excess as well. So this question to, are the cosmetic procedure covered? So we got the answer, cosmetic procedure unless medically necessary. So it's expected line, and we'll try our third out of the scope question, which is not in document. What is the capital of France? But you want to make sure that it just does not get the answer from model, but instead it returns us back saying that I do not have that information in the document. This is a very important thing, and I think while this is running, many of the agents fall back on the universal knowledge or the pre-trained knowledge of a model. And ideally, when we are building a model for retrieval augmentation or specific use cases, we should avoid falling back, or we should build a resiliency enough that information is based on information that we have provided or retrieved, the answer appears. And if the question is not within that scope, then it should come back with a clear denial instead of augmenting it based on a training material. So here, what is the capital of France? I'm sorry, but the information is not included in the policy document. So this is a very good so far. Step 7, building the claim agent multi-turn. The A2A protocol also supports the multi-turn interaction, where the agent can request additional inputs from the client mid-task, such as like input required state. And this is what we are going to demonstrate as simple standalone agent. So let us run it. Okay, the class has been initialized. Now let's test the multi-turn. So we got input required. If you recall the earlier sessions, we have described the terminal states and also the follow-up states, where the input required does go back on processing states, one of the processing state, and then if the information is provided correctly, then it again find back self into termination state. So here we are going to provide that information. And by the way, if you have seen it, we will maintain the session ID, and that's how the correlation is actually handled. So session ID was created here and session ID was passed here. That's how the agent will ensure the memory is maintained. Memory is a very important aspect in building agents. We are currently focusing on A2A protocol, but building agent itself, it's an art, and we will come back with some nice tutorials on what are the areas we need to look for when we are building agents as well, and what are the best practices. So well done. It has completed. It has built a claim receipt, and the whole information has returned with the perfect status completed. So it has reached the status into terminal phase. The multi-turn documentation, what we have done, you can here see in a sequence diagram. It's the same thing what we did and what we demonstrated. Now we are building a policy summary agent. So let's run it. We got a policy summary agent, and now we are just trying to summarize a policy. So it's the same knowledge base that we have provided, but based on that, we will just simply use it for summarization of the policy. So if you see in the summarization, what we have done is we provided a knowledge path, which is here, provided the model information and everything, and then we instructed the model that provides us the summary in certain structure. This is very important when we are building agents as well, because agents has data parts, and data parts sometimes may not be strongly structured. So how to encourage agents and models which are probabilistic to produce some deterministic structure. And more we master the art of prompting and correct weightage, we can actually get near to deterministic structural outcome. So we got it. Now you can see it has delivered in a very good way. Covered services and exclusion. It's a wonderful way of summarization. These agents are very useful for especially if they're connected with the voice agents as well, because when automated marketing calls or when user query calls comes, this provide a wonderful way of augmenting large amount of data into summarized documents, and then we can actually deal further with that particular kind of request, especially it's coming from voice agents. Multi-skill routing, you can read it. It's again a sort of another type of agent that we have written, and it demonstrate various capabilities around skills. So it got a skill routing now, and we have created 3 skills: policy question and answer, claim filing, and policy summary. So let us basically run those skills. This skills has the similar design or architecture, like what you call it, cloud skills or any other GitHub Copilot skills. So there is nothing much difference in terms of principle what skills are, but it's just a different way of implementing the skill. Most likely in programmatical way, we will be implementing the skills using program itself. So you can see here, multi is basically a multi-skill agent, and we are running. So when we run this test, what should resolve to who? You can see that when somebody is asking premium, it's moving to the policy QA skill. I need to file a claim, it's moving to the claim filing skill. Give me a summary of a policy, it's going to the policy summary skill. And these skills can actually be also routed to different agent down the line as well. So it provides a very insightful and comprehensive asymmetrical horizontal integration with multiple agents. And this is now we are moving into the much more real life use cases. In real life, agents are not just one class. In real life, agents are a combination of hundreds of different classes communicating to each other, working on different knowledge bases, providing bias or unbiased output, and then assembling the final result back to the original request. So in real world, agents are never going to be a linear or symmetrical. So well, we did the policy outline, and we did the claim filing using the skill. You can see here, we did the claim filing using the skill. And now we are waiting for the final response. I know it might sound overwhelming when you're running this first time. I would recommend you to give a good run, give a good reading, one time, twice, thrice, maybe a little bit more. Writing agents is abstract thinking, and for anyone who has not developed that area of a skill, it's sometimes find a little bit confusing. And there's nothing to be wrong about, because not everyone learn abstract thinking in a very early stage of career. So if you are at the early stage of career and if you find this little bit overwhelming, instead of giving it up, I would recommend go through a couple of times, build the patterns of thinking in abstract way, and then the agents will make much more sense that how this whole thing is working flawlessly. Because if you see here, we haven't got any deterministic code logic, but still the outcome is near to deterministic. And that's the idea of agents. We don't want to code the business logic, but we want to direct agent to build the business logic as part of their abstract declaration, as part of their abstract definitions, and then generate the near deterministic or absolutely deterministic outcome. And this is what we see here. And this is all happening using the Phi-4, which is very entry level model. So you can see that writing a good agent is actually how important it is to write agent in the right way, and using agent in the right way, even the entry-level model can perform really brilliant work. Not everything need to go to the super smart models. Of course, if we use super smart model, we can solve many complex problems, but not all the problems deserve those super smart models either, and they're very costly as well. So now we are going to go for a small experiment, how much the monthly premium and also thing, and it will load the skills and it will show us the result. There you go. Policy QA, text completed, everything just looks good. So we have covered practically everything that A2A does offer as an agent: multi-turn, artifacts, data part, multiple skills, task lifecycle, and text part. These are agents. We have just built an agent. Now, in the next subsequent sessions, we will explore them, how to embed them as a server, and then using the client, start consuming them. But I hope you like this particular example. End of this lesson, you have working QAAgent that answer insurance question using the Phi-4. It's tested in a standalone in a notebook. In the next session, we will wrap as a discoverable A2A session. Thanks for watching this lesson on LocalM Tuts. In next lesson, we will wrap this agent in a fully discoverable A2A server with an agent card and HTTP endpoint. You find the next video in the A2A protocol course playlist, which is available. The link is available in the description, and I see you there in the next session.